Hey guys, welcome back. I'm going to start into the next chapter, solving equations, both exponential and logarithmic, from the feedback I got from both you guys and some parents. I think this is probably the way to go moving forward. So we are going to do the next chapter again on exponents and logs. The last one we did was also exponentials and logarithmics, but basically we were studying their graphs and the functions. In this chapter, we're going to take a closer look at how we solve their equations, okay? So at the top of the page here, under overview, it basically tells us that in this unit we'll solve problems involving exponential equations with and without common bases, problems involving log scales. We'll also demonstrate an understanding of logs by expressing a log equation as an exponential function and by determining both what we call exact and approximate values. Okay, there's a big difference between those two, and when the time comes, I will discuss what those are and how we're supposed to express our solutions. Okay, values for log expressions, and by developing and applying laws of logarithms. Again, we took a look at those a little bit this year. You were first introduced to them in either grade 9 and 10, and then you do a little bit of work with them each year moving forward, so that should be nothing new to you. Okay, so just the first section here, solving equations with rational exponents. And what that's going to look like is when we have a rational number, okay, which will be our exponents in this case, a rational number is a number that can be written in the form a over b, okay? So to you guys kind of looks like a fraction, so that's what our exponents are going to look like in these questions. Now it says we have already met this concept in earlier courses. Consider the following example. The volume of a beach ball is 50,965 cubic centimeters. Determine the radius of the ball, so they're looking for the value of r, okay, to the nearest tenth, one decimal place of a centimeter. And again, they're nice to you. They give you the volume of a sphere. Okay, anything that deals with the question on surface area volume of a composite shape or a three-dimensional shape, they will provide the formula for you, so don't worry about having to memorize those. Now, it says Sarah and Lee are solving the problem, and the first four steps in their solutions are identical as shown below. So they start with the formula. They then substitute in the given volume for V. They then divide both sides of the equation by 3 to remove the 3 in the denominator right here. And then divide both sides of the equation by 4 pi, okay, to remove the 4 pi that's right here, so that we have isolated r. Now, at this point, it's r cubed, okay, but we have r all by itself on the right-hand side of the equation. So starting with Sarah, it says Sarah completed the solution by taking the cube root of each side. Complete Sarah's solution. So what she does is she takes the r cubed, okay, and it says she takes the cube root of each side. So she's going to take the cube root of r cubed, and if I do that to the left-hand side, I then have to take the cube root of the right-hand side, okay? So I'm going to take the cube root of 3 times the 50,965 all over 4 pi, okay? And when I do that on my calculator, you'll see that we end up with a value for r to the nearest tenth, as they indicated. It'll be 23.0 centimeters, okay? So that's the value or the solution that basically Sarah gets, okay, for her calculation. Now, going over to Lee, it says Lee completed the solution by raising each side of the equation to a specific power. Which power did he use? Well, Lee raises each side of the equation to a power of 1 over 3. Now, the reason he does that is the following. If I have r cubed, and I want to have just r, that means using my laws of exponents, I have to multiply by 1 over 3, right? Because what I would do in this case is I'd go 3 times 1 over 3, and that would give me 3 over 3, which is r to the exponent of 1, which is what I want, just r. So basically in these questions, the students will end up with the same answer. One discusses calculating the solution by taking the cube root. The other student talks about calculating the solution by raising each side of the equation to a specific power, which we call the reciprocal, okay, of the value that is attached to the variable. I'll show you guys that in the notes coming up here very, very soon. So what happens is the following. On the left-hand side, the r cubed is raised to the exponent of 1 over 3. And if I raise the left-hand side to an exponent of 1 over 3, I must do the same thing to the right-hand side, okay, which I will write out here for you guys, okay? So over 4 pi, and this whole value on the right-hand side is now also raised to an exponent of 1 over 3, okay, which will also give me a calculation of 23.0 centimeters. Okay, so again, like I mentioned, both students, same solution. Okay, but thought of in two different ways. Now, the guy at the fake stop sign here again says, use the following procedure to solve an equation where the exponent is rational. Raise both sides to the reciprocal power of the exponent. So again, that means if I had 7, the reciprocal would be 1 over 7. If I have 2 over 3, the exponent would be 3 over 2. Okay, and then simplify and solve for the variable. So 3 warm-up questions here, kind of using those basic ideas. I have x to the exponent of, right there, x to the exponent of 1/2. So what I do is I take that x to the exponent of 1/2 and I raise it to the reciprocal of 1/2, which is 2. So I squared the left-hand side, so I must square the right-hand side, okay? What will happen here is you're left with x, and 7 squared, okay, that's 49. And that's it. There's your solution for the first example. In the second one, okay, I'm going to do the same basic idea, but what you have to be careful of here is that this exponent of 1 over 3 is only belonging to that variable x. It does not belong to the 2. So the first thing I actually have to do in this question is divide both sides of the equation by 2, okay, like so. Now I can take that x to the exponent of 1/3 and raise it to the reciprocal of 1/3, which is 3. Okay, so if I cube the left-hand side, I then have to cube the right-hand side, like so. Okay, now I have a negative value, and if I'm cubing it, the answer will still be negative. 1 cubed is 1, and 2 cubed is 8. Okay, and there's your solution. So on this side, you just have x. So x is equal to negative 1 over 8. Okay, C starts out the same way. That exponent of negative 2 over 3 here is only attached to the x. So I divide both sides by 5 to start the question. Okay, and that leaves me with 9 on the right-hand side. Now, to get rid of that exponent of 2 over 3, okay, which I have here, I have to raise both sides of the equation to negative 3 over 2. Remember, I want it to be positive, so I have to multiply by a negative so that my solution is positive. I raised the left-hand side of the equation to negative 3 over 2, so I must raise the right-hand side to the exponent of negative 3 over 2, like so. I will be left with x here, but on the right-hand side, because my exponent's negative, it becomes 1 over 9 to the exponent of 3 over 2. Okay, and what does that mean? Well, that means that I want to do what? I want to take the square root of 9, which is 3, and then I still have to cube it. So my answer here will be 1 over 27. Okay, and there's your answer. So remember, when I have a rational exponent, the bottom number tells me the index of the radical. So take the square root of 9, and then I raise it to the exponent of 3 after that. Okay, and that's how I get the 27 in the denominator. Okay, next page. So on the next page, they basically talk about what an exponential equation is, okay, and it's probably a good idea if we just basically highlight what an exponential equation is, okay, and we underline those key points. And yeah, so like here's an exponential equation in bold, and it's an equation where, and like I mentioned earlier on, the variable, okay, is the exponent. Okay, another key point is the next step here, okay, which says many exponential equations can be solved by writing each side of the equation using the same base, okay? So remember, when they are talking about bases, okay, that when I have a power, so for example, x to the exponent of n, that whole thing is a power. This is the exponent, but x, okay, that's the base. So when they're talking about common bases, they're talking about the larger number, okay, in your power. So the example they give us here is 36 to the exponent of x. 6 squared, okay, is the 36. And then it's still to the exponent of x. And then if I have 2 to the exponent of x right here, then I just multiply them together to get 2x. So you've rewritten 36 to the exponent of x as 6 to the exponent of 2x, okay? Now, let's take a look at some examples. And again, I'll discuss all these as I work through them. The first question here, you guys, they take 9 to the exponent of 2x, but they want the base to be 3. So the number 9 that they start with can be written as 3 squared. So there's your number 9. Now that number 9 is still to the exponent of 2x. So from here, what do I do when I have a power raised to another exponent? Well, I multiply the exponents together. So 2 times 2x is 4x, and there's your solution. Okay, there's your simplified expression. So 9 to the exponent of 2x is now written with a base of 3. Okay, in B, Okay, they want 125 to the exponent of 2 minus x. So 125 is the base now. They want the base to be 5. So instead of 125, that's actually 5 cubed. So 5 cubed is your number 125, but it's still to the exponent of 2 minus x. So just like in the previous example, when I have a power raised to another exponent, I have to multiply the exponents together. But be careful here because I have two terms outside. So I have to go 3 times 2. So that will give me 6. And then I have to go 3 times the negative x, which is minus 3x. So there's your solution. Okay, 5 to the exponent of 6 minus 3x. In C, okay, we are multiplying here. Okay, so that's a big deal here. So they want everything to be base 2. So the number 8 is 2 cubed. Okay, so there's the number 8 times. Now 16 is 2 to the exponent of 4. So there's your 16, but it's still to the exponent of x. Okay, so I've written both of those individual values with bases of 2. Now this 2 cubed, I'll leave this 2 cubed as 2 cubed for right now, times, here this is now 2 to the exponent of 4x, isn't it, right? A power raised to another exponent, I multiply the exponents together. Now using more laws of logarithms, I am now multiplying powers that have the same base. So in this case, I add the exponents. So this is 2 to the exponent of 3 plus the 4x. Now I can't do anything further from there because 3 and 4x are not like terms. Okay, the 3 doesn't have an x to add to the 4x. So I can't go any further or simplify it any further than I did just there. So it's 2 to the exponent of 3 plus 4x. Okay, in D, okay, I want to rewrite this expression. So basically I'm taking a look at 512 and I want that number to be 2. So I'm going to talk about this, 1 all over. Now 512 is actually 2 to the exponent of 9. That gives me 512 and it's still to the exponent of 3x. So when I simplify the denominator, this is 2 to the exponent of 27x. Okay, so hopefully that makes sense. Now I want to bring that number 2 up to the numerator. So if I do that, that means I have to make the exponent negative. So this is going to be 2 to the exponent of negative 27x. Okay, so there is your solution to D. Now in E, okay, a little different. This whole thing is your base. So 16 over 81 is your base. They want it to be 2 over 3. So instead of 16 over 81, it has to be 2 over 3. Well, how do I make 2 over 3 16 over 81? I raise each of those numbers to an exponent of 4. Okay, so 2 to the exponent of 4 is 16. 3 to the exponent of 4 is 81. So there's the 16 over 81, but it's still to the exponent of x plus 5. So again, a power raised to another exponent, I just multiply the exponents together. So this is going to be 2 over 3 to the exponent of 4 times x. So that's 4x. And then 4 times 5, which is a positive 20. Okay, good. So those are just converting expressions to different bases. The reason we do that is because we really want to move on to solving equations, okay? And to do that, we use the same basic principles. So it says an exponential equation is an equation where the variable, okay, is the exponent. So use the following procedures. So first thing is write each side of the equation in the same base. Now, you won't always be able to do that as we move through the chapter, but for the first couple lessons we will, and that's kind of always your first look to see if we can do that. If necessary, use exponent laws so that each side contains only one base. At that point, equate the exponents and then determine the value of the variable. Okay, so those are the steps that we're going to use when we solve them. Okay, we'll use all of them or 2 or 3 of them or just one of them depending on how difficult the question is. So on page 247, the first one, 5 to the exponent of 2x plus 3 equals 5 to the exponent of 7. So I do have one power on each side, and they already have the same base of 5. So I can move on to the step where I basically equate the exponents. So the 3 dots mean therefore, I can just say 2x plus 3 is equal to 7. Okay, and then it's a very simple two-step equation. So 2x will equal 7 minus 3, which is 4. And so x will equal 2. Okay, so there's your solution. Now, just as a side note here, whenever we're dealing with equations, whether it's exponentials, logarithmics, quadratics, linear, it doesn't matter. The nice thing about them is I can always take my solutions and check to see if they are correct by substituting them back into the original equations and seeing if the left side equals the right side. Okay, basically we say, we're checking to see if it satisfies the equation. So in this case, if I were to verify my solution or check okay, to see if it's correct, I'd simply go like this. So 5 to the exponent of 2 times x, and my x value is 2, plus 3. That should equal 5 to the exponent of 7. So this will be, okay, 2 times 2, that is 4. 4 plus 3 is 7. So I do get 5 to the exponent of 7 equals 5 to the exponent of 7. So that means my solution of x equaling 2 was correct. Okay, on to the next one. So in the next one, again, I have 1 power on each side, but their bases are different. Okay, I have 7 and 343. So what will happen is I'll have 7 to the exponent of x minus 2. I'll probably have to change 343 into 7 to the exponent of something, and that will be 7 to the exponent of 3. Okay, that's what 343 is. Now I have a situation very similar to A. So I have 1 power on each side of the equation. They do have the same base. So I can basically say therefore and equate the exponents. So in this case, you'll get x is equal to 5. Okay, look at me using different colors now. Crazy times, crazy times. Okay, into C. So now in C, I want to take a look at the bases. It's 3 and 81. Okay, they are not the same. I'm going to try and create common bases. So the base of 3, I'm not going to be able to do much with that, but 81 I can write as 3 to the exponent of 4. So there's my 81, and I have to raise that to the exponent of 3x. Okay, so the left-hand side is going to stay as 3 to the exponent of 5x minus 1. On the right-hand side, I now have 3 to the exponent of 12x, 4 times 3x. I've gotten to the step I want where I have 1 power on each side with a common base, so therefore I can just say that the exponents have to be equal to each other, okay? And then I'm going to solve for x. So this will be 12x minus the 5x, so negative 1 will equal 7x, and then divide both sides by 7. So negative 1 over 7 is equal to x, okay? And there is your solution for C. All right. Now in D, okay, a little bit more work in D. Okay, and this is a very typical type of question that you would see probably in a written portion of a test or a quiz. Okay, just a little more difficult on the right-hand side. So the left side is 3 to the exponent of x. Okay, no problem there. Now this is 27 times the square root of 3. So the 27 is 3 cubed. Okay, there's 27. What you have to do is write the square root of 3 as 3 to the exponent of 1/2. Okay, that's how we write the square root of something. It's the same as writing something to the exponent of 1/2. So the left-hand side stays as 3 to the exponent of x, but the right-hand side is going to be 3 to the exponent of, now I'm multiplying powers with the same base, so I have to add the exponents. So you're going to have to add 3 plus 1/2. Now when you do that using common bases, the 3 will be what? 6 over 2 plus 1 over 2, which is 7 over 2. So this becomes x to the exponent of 7 over 2. And pretty easy from this point. Now you just equate the exponents. So x is equal to 7 over 2. And there are no extra steps that are needed. Okay, that's your final solution. Moving on. Now, a word problem. Okay, but it's going to be the same basic idea. It says basically from here, okay, that they want us to do the following, or they give us the write-up. A bacterium triples every 6 days. Okay, the number of bacteria, which is n, present after x days, so x is the number of days, is given by this equation. Okay, so they give you the formula that you're supposed to use right there. After how many days are there 243 bacteria? So remember, n was the number of bacteria, so I simply replace n with 243. So I have 243 is 3 to the exponent of x over 6. When I solve this, okay, what I'm going to do is I'm going to rewrite 243 as a power that has a base of 3, and that's 3 to the exponent of 5. That's 243. So what I've done here is created powers that have the same base, right? So from the previous examples, we should now know that when I do that, I have powers with the same base. I can basically equate the exponents. So I can say 5 is equal to x over 6. And to isolate x or get x by itself, I'm going to multiply both sides by 6, okay, which will leave me with this. And from there, we can then say that 30 is equal to x. Okay, it's a word problem, so I just make a little statement. X was the number of days, so this is just 30 days. Okay, that's what we are talking about there. All right, good. Okay, next question. Okay, what they want us to do here is solve the same equation, but 2 different ways. So in A, they want me to solve it graphically, and in B, they want me to solve it algebraically. Okay, and they even tell me to do that by creating common bases. Okay, so we'll take a look at that in a second. So what I would do, okay, in A is I would graph the left-hand side of the equation as y1. So y1 could be 27 to the exponent of x minus 2. And then what I would do is I would graph the right-hand side of the equation as y2. So that's 1 all over 81 to the exponent of x plus 3. And then what I would do is I would figure out where those two graphs intersect, right? And I want the x value of where they intersect. So when you do that, you will see that they intersect, okay, at an x value that is negative 0.8571429, okay? And again, converting that to a fraction, you will see that that is approximately, or exactly, I should say, negative 6/7. Okay, so try that. Make sure you can get that as your answer before we move on to B, because we're going to compare the answers and see that they are exactly the same. Now in B, I want to convert to common bases. So that means I'm focused on the bases right now of 27 and 81. Okay, the common base is going to be 3. So 27 is 3 cubed. So there's 27. It's still to the exponent of x minus 2. On the right-hand side, I have 1 all over, and in the denominator, 81. That's 3 to the exponent of 4. So there's the 81 to the exponent of x plus 3. So simplifying each side of the equation, on the left-hand side, I'm going to have 3 to the exponent of 3x minus 6. Okay, and again, remember that comes from 3 times x, the 3x, and 3 times negative 2, which is the negative 6. Okay, similar idea on the right-hand side, but it's in the denominator. So this is going to be 3 to the exponent of 4x plus 12. Okay, now I want to bring that expression on the right-hand side up to the numerator. So when I do that, the exponent has to become negative. Now, in order to do that, I have to multiply both terms, because it's a binomial, by the negative 1. So negative 4x minus 12. Now I've created powers that have the same base, so I can equate the exponents. 3x minus 6 will equal negative 4x minus 12. So we'll get the x's on one side of the equation, okay, and the constant values on the other side. So negative 12 plus 6. So this will give you 7x is equal to negative 6. From there, divide both sides by 7, so you'll get x is equal to negative 6/7, which was the same value we got when we solved it graphically in part A. Okay, so work on that tonight, see how you guys do, and obviously any questions, email me, and I'll have another lesson up in the next couple days, and good luck with it, and yeah.